Welcome to Spring LIB.
Our question says that we have a kite string of a radius of 2 millimeters, which I write here as R, and it's extended directly upward at 0.8 kilometers, and I write that as H, the height. And it's coated with a 0.5 millimeter layer of water. I write that layer as T for the thickness of the water, and that water has a resistivity rho of 150 ohm meters. If the potential difference between the two ends of the string, which I write as V, is 160 megavolts, what is the current through the water? So it wants us to calculate the current from the information given. Notice I put everything in terms of meters here, and then I also put the volts in terms, the potential difference in terms of volts, not megavolts. So we're using all SI units. So first we want to calculate the resistance of the water here, and then we can use Ohm's law to get the current. Well, the resistance is equal to the resistivity times the height divided by the area. Okay, well, we know rho and H, so we need to find the area, but the area is just pi times the radius, since we're going to use it spherical, times the radius squared, okay? But the radius of the water is, we have the radius of the string plus the thickness of the water squared minus the radius of the string squared, because we're just considering the water here. All right, so we plug all the values that we have into this expression, and this comes out to be equals here 1.698 times 10 to the 10 ohms for the resistance of all the water. So the current then can be calculated as I is equal to the potential difference V divided by the resistance R. So you plug in the value for V that we were given and the value for R that we just calculated, and this is 9.42 times 10 to the minus 3. And the units of the current is amperes. We can box that in as our solution to the question.